Hi friends, in this video we are going to solve traveling salesman problem by using branch and bound method. So traveling salesman problem you already see in previous units by you solving various methods. So in this we are going to use with branch and bound. So already you people know. So for this this is what the sum given. So I am starting with A, and we have for traveling salesman problem we have to visit all the nodes and back to the source node. So in this we should have minimum traveling weight we have to find. So which node to be visited first and which will be the second, that have to be calculated by using branch and bound method for traveling salesman problem. So initially so for example, initially if I start with if I go with A to B, so I can also we have adjacent nodes A to B, A to D and A to C. So if I want to visit with the three nodes and A to E, so these are the adjacent nodes I have for A. And for three nodes, if I choose with A to B, after B I can visit to C, or A to B I can visit to D, or A B I can visit to E. So these are the possible ways. So if I choose this one, so A to B, B to C, after C I can visit to D, or I can visit to E. So this is also a possible solution. So if I started with E, then A to B, B to C, C to D and D to likewise after D I can move to E. So from E I can move to A. So these are the possible solutions. Likewise I can go with the next node visit. So for that, by using branch and bound we are going to calculate. So initially I am going to, for this also we have a state space tree. For initially we have to calculate node 0. So for this, so we have to write the nodes A, B, C, D, E. So for this, so this is the 0th node. So this will be useful for next upcoming steps also. So keep it safe. And for this we have adjacent nodes. For A we have adjacent nodes B, C, D and E. So among this we have to get two minimum values. One is A to C, another one is A to B. So A to C plus A to B. So this will be A to C is 1 plus A to B is 3. So answer is 4. Next, for B we have adjacent nodes. For B we have adjacent nodes A, C, D and E. So among this minimum values are 3, 6. So for this A to B is 3 and B to C. B to C is 6, value is 9. And for C, so for C I have adjacent nodes A, B, D and E. So for this I have minimum value is A and then E. So for this AC plus CE. So my value is 1 and 2. And for D, so adjacent nodes A, B, C, E. So for this minimum value is E and C. So DCD plus DE equal to CD is 4 and DE is equal to 3. And then for E I have adjacent nodes A, B, C and D. So among this I have CE plus DE. My value is 2 plus 3. So this is what the value I got. So this is 3 and this is 7 and this is 5. So I have to add this one. 4 plus 9 plus 3 plus 7 plus 5 and divided by 2. And this is the formula. 10, 15, 90. So this is the total value and divided by 2. 28 divided by 2, it is 14. So for here you have to fill lower bound is equal to 14. So from this, so we have to start. So from A node, where we are going to move to the next position. So that have to be taken. So A's adjacent nodes are B, C, D and E. That we are going to calculate now. So it is A to B, A to C, A to D, A to E. So likewise from A I can move to A, B or C or D or E, and for this I have to find the lower bound values. For lower bound values I can make this particular node as node 1. So in short I specifying as N. So it is node 2 and it is node 3 and it is node 4. So now initially I will show you the node 1 and the remaining 3 nodes I will calculate and tell you the answer. So it is node 1. So for this also I have to write all the nodes. So here, so we are calculating A to B. So this can be rewritten as AB. So here I have A. So I have to mention A plus B. For B also I can write A plus B. So these are the two answers I already got. Then I have to find the remaining two values. From the zeroth node, AB is already calculated. So AB is already calculated and remaining one value is AC. The next minimum value. So it is 3 plus 1 equal to 4. Next is AB. AB is already calculated. Plus next value is B plus C. So it is 6. So it is 9. So remaining values from the node 0 we can rewrite. So it is written as AC plus CE, CD plus DE, then CE plus DE, 1 plus 2, 4 plus 3 and 2 plus 3, 3, 7 and 5. So for this value is 4975 and for this also answer is 14. For the same level node I am calculated. So for node 2 it is A to C, and for node 3 A to D, and for node 4 A to E. So for this I wrote we have to write all the nodes and A to E, and here also all the nodes. So for this we have a combination A to C and C to A. So for A I have to write AC, and for C also I have to write A and AC. So for this remaining rows, so we have to identify the next smallest element. So for in the node 0, so in the node 0 mean this node, so AC is already found and next value is AB. So I wrote AB next value, and then for C, so already we wrote AC. So next was smallest element is CE. So CE is taken here. So next we are substituting the values and value is 14. So that have to be written in this position. For node 2 it is 14, and for node 1 also it is 14, and for node 3, so AD, and for D also AD is mentioned, and remaining nodes are taken from 0th node. And for this, next smallest element is AD, next first smallest element is AC. So AC is written here, and then here AD is finished. So next for this AD we don't have, the smallest element is DE. So DE is mentioned and values are substituted. Answer for this is 13. In the same way, here also we identified the values. So for this, total is 31 and it is divided by 2. I have, it is like 15.5. So I go with a lower value, lower bound. So it is 15. So here I am mentioning 15. And for this value, it is 20. So among this, both the values have 14. And next is 15 and 20. Lower value is 14. So from this first node, I am going to take. So I am expanding from A. So from after A, I can visit to B. So from B, the adjacent nodes are C, D and E. So that is extended here, C, D and E. So for this, we are going to calculate the values. So this is node 5, node 6 and node 7. So I am showing how to calculate node 5. So this is the node A to B and B to C. This is node 5, A to B and B to C. So we are going to calculate that one. So here we have to write A, B, C, D and E. So first, so we can write this as AB, BC. These two combinations we can write. So here for A, I can write as AB, for B also AB, and then for B, I can write BC, for C also I can write BC. So remaining values, so this will be next lowest value, this will be the next lowest value, and remaining things, these two values can be taken from 0th node. So here it is AB. AB is already taken. Next value is AC. So AB value is 3 and AC value is 1. AC value is 1. And then for this, AC value is 1. And then for C, here we have BC. So we don't have option BC here. So next minimum value is AC, it is 1. So AC, it is 1. And for BC we have value, for BC we have value 6. For BC we have value 6. So that have to be written here. And for this, AB value is 3 and BC value is 6. So 3 plus 6. And D value is 7 and E value is 5. 7 plus 5. So 4 plus 9 plus 7 plus 7 plus 5 divided by 2. And this value is 32 divided by 2 and the value is 16. So this value have to be written in the lower bound 16. So likewise I am going to calculate for n 6 and 7. So for node 6, we have A to B, B to D. So this can be written as AB and BD. So for all the nodes are written, So for this AB is written, and for B, we can also write AB, and for this BD, and for this BD can be written. So next minimum value is AC, and this minimum value is DE, and the values are substituted and we got 11. And for node 7, so in the same way, for A we have AB, and for this one AB, and for BD, for B also we written, and E also we have written. The next minimum value is found for this and this, and the values are substituted and we got answer 19. So these values are substituted in the state space tree. So from this minimum value is 11. So from this A to B, so we have A to B and B to D. After this we have adjacent nodes C and E. So that can be written in two ways. So from this I can divide A to B, B to D and D to C, and then another one is A to B and B to D and D to C. So this is what I have to calculate. Lower bound for this lower bound. So now I am going to show node 8 for this A to B, B to D, D to C. So this can be written as AB, BD and DC. So in this way we can write. So A, B, C, D, E can be written A. So for this, so for A, for A also we can write A, and B, AB. For this B, so BD, and for D also BD, and here it is DC. For D it is DC, and for C also DC. So next minimum value we have to find from the node 0. So in this node 0, so first is AB. So from node 0, AB is already there and AC is the next value. So we have to find AC, and the value is for AB, the value is 3, AB value is 3, and for C it is 1. And then for C and D, the value is AC is the minimum value. Next minimum value is AC. So AC value is 1 and DC value is 4. So E value is 5. So we are supposed to substitute. So from this AB value, is AB value is 3 and BD value is 7, and for this BD value is 7 and DC value is 4. So these are substituted. So after substituting the values, we totaled the values and divided by 2, and final answer is 17. Then that is filled with the node 8. So here it is node 8, it is 17. So node 9 value is also calculated, and for that we have 16. So for this 16 is entered. Compared to these two, this will be the lower bound. So A to B, B to D and D to E. Then we can move to the remaining one node is C. So A to B, B to D, D to E and then C. So this is what the root value. So I am calculating for this A to B, B to D, D to E, and E to C. So for this we have to calculate. So for this we have to calculate A to A B, B D, D E, and E C. So for this we have A B. For B also we have to write A B, and for this B D, for this B D, and for this it is D E, then for this also D E, for this it is E C, and here it is also E C. So this value and this value we are supposed to found from the node 0. So next remaining value is lesser value is AC, so C is already found. Next remaining end value is AC. So AC is written, and the values we have to substitute and identify the lower bound value for this particular sum. So the values are calculated, and we have 40 divided by 2, and the value is 20, and this lower bound value is substituted in the node 10. So this is node 9 and this is node 10. So this is what the route we are going to travel: A to B, B to D, D to E, E to C. So this is what the value final solution for this particular traveling salesman problem. Thank you. And this will be the final tree, state space tree. Thank you.